Hello and Assalamualaikum. My name is Muhammad Zafri bin Hisham with the metric number of 213068. Today I will be discussing with you all question number 14 in tutorial 4. This question, this question lies under chapter 20, which is the kinetic theory of gases. First of all, I am going to read the question. A 1.0 mole sample of oxygen gas is confined to a 4.93 liter vessel at a pressure of 7.98 atm. Find the average translational kinetic energy of the oxygen molecules under this condition. First and foremost, we must list down the data that is given to us in a simple fashion. For example, N being the number of mole is equal to 1, while V being the volume is equal to 4.93 liter. In this topic, we must convert all unit into its SI unit, and the SI unit for volume is cubic meter. In order to change liter to cubic meter, we must times 4.93 by 10 to the power of negative 3. This will give us 4.93 times 10 to the power of negative 3 cubic meter. The pressure is 7.98 atm, and the SI unit for pressure isn't atm, it is Pascal. 1 atm is equivalent to 101.325 kilopascal. So in order to convert atm to pascal, we must times 7.98 times 101.325 times 10 to the power of 3 pascal. This will in turn give us 8.08 times 10 to the power of 5 pascal. The formula for translational kinetic energy will be 3 over 2 times kb times t. Kb being the Boltzmann constant with the number of 1.38 times 10 to the power of negative 23 joule per Kelvin, while T is the temperature. As we may know, the question does not give us temperature at all, but it gave us the volume and the pressure. The equation for ideal gas law is pressure times volume equals to number of molecules times Boltzmann constant times temperature. In this equation, it does give us temperature. So after rearranging it a little bit, we will get temperature is equal to pressure times volume over number of molecules times Boltzmann constant. After we have obtained this equation, we must substitute it into the formula, giving us 3 over 2 times Boltzmann constant times pressure times volume over number of molecules times Boltzmann constant. We must now cancel out the Boltzmann constant, and this will give us 3 over 2 times pressure times volume over number of molecules. The question also does not give us the number of molecules, rather it gives us the number of mole. The formula for number of mole is number of molecule divided by Avogadro's constant. After rearranging it, as like we do in the ideal gas equation, we will get number of molecule is equal to Avogadro's constant times number of mole. So the Avogadro's constant is 6.022 times 10 to the power of negative 23. After we have successfully get this equation, we have to substitute it into the formula, giving us 3 over 2 times pressure times volume divided by number of mole times Avogadro's constant. After we have successfully reached this point, we must now key in the data that we have gathered all along. Okay, so it will become 3 over 2 times 8.08 times 10 to the power of 5 Pascal times 4.93 times 10 to the power of negative 3 cubic meter divided by 1 mole times 6.022 times 10 to the power of negative 23. This will in turn give us 9.9 times 10 to the power of 21 joule per molecule. Alright, that will be all from me. Thank you all for listening to my presentation and have a good day ahead. Goodbye.